What is a cryptographic hash function for secure passwords? Imagine trying to hide a secret so well that no one can ever figure out what it is, even if they get hold of the hiding spot. That's kind of what a cryptographic hash function does for passwords. It takes any password you give it and turns it into a fixed string of characters, called a hash. This hash looks like a jumble of letters and numbers, a kind of digital fingerprint of the original password. The magic is, you cannot reverse this process easily. Even if someone gets access to the hash, they cannot figure out what the original password was. This makes cryptographic hash functions perfect for storing passwords securely. When you create a password for a website, the system doesn't store the actual password. Instead, it applies the hash function and saves the resulting hash. When you log in later, the system hashes the password you enter and compares it to the stored hash. If they match, you're in. This way, even if hackers steal the database, they only get the hashes, not your actual passwords. There are some key features that make these hash functions good for security. First, they are deterministic, meaning the same password always produces the same hash. This allows the system to verify your password without storing it. Second, they have preimage resistance, which means it is practically impossible to reverse the hash back into the original password. Third, collision resistance makes it extremely unlikely that two different passwords will produce the same hash. Lastly, the avalanche effect causes small changes in the password to produce completely different hashes, making it harder for attackers to guess or match hashes. To make password storage even safer, developers add a unique random value called a salt to each password before hashing. The salt is different for every user, so even if two people choose the same password, their hashes will be different. This stops attackers from using pre-computed tables called rainbow tables to crack passwords. Popular algorithms used for secure password hashing include bcrypt, Argon2, and SHA-256. These are designed to be slow enough to prevent rapid guessing attacks. They requiring more computing power, which makes brute force attempts take longer and become less practical. The process for storing passwords securely involves generating a unique salt each time a user creates or updates their password. The salt is combined with the password, then hashed with a cryptographic algorithm. The system stores both the hash and the salt in the database. When the user logs in, the system retrieves the salt, hashes the entered password with it, and compares the result to the stored hash. If they match, the user is authenticated. This approach keeps passwords safe from theft and misuse. It ensures that even if a database is compromised, the passwords remain as protected because attackers only see the hashes, not the actual passwords. For backend developers working with APIs, databases, and server-side logic, using cryptographic hash functions with salting is a best practice. It helps protect user data and keeps authentication secure.